Hello all. So let me introduce myself again. So there are maybe new joinees here. So I am Swapnil Mane, a PMRF research scholar at IIT Jodhpur in CSE department. I'm working in social network analysis and application group. My primary area of research is in social network analysis and natural language processing. Yeah, we'll start this live session, which is about week ties more about. It is an week three. Okay. Yeah, let's see the first question. Start from the first question, which is about consider the following definitions of a local bridge. So there are four definitions has been given here. Okay, and the we need to identify which definition is and more related to the local bridge. So the first definition, which is an age with zero neighborhood or neighborhood overlap. This is it is claimed. So it is related to the local bridge or not, that we need to identify that. Okay. First of all, we need to understand what is an local bridge. Okay. The second definition, which is an age whose endpoints have no friends in common. Maybe this isn't related. Recall the neighborhood overlap and uh, what is a neighborhood overlap, and it is like the conceptual and similar. Let's see. First, I will read the definitions and then we'll go in depth of the concepts of the neighborhood overlap and what is in common friends of the endpoints of the age. Okay. The next, which is in third definition, has been given as an age whose deletion results, means age has been removed or deleted from the network, and increase the distance between the endpoints. Endpoints means 2 points to have a value strictly more than the two. Okay, so you there are let's take in two nodes and we have removed the age or deleted the age in between the those nodes. The distance between the two nodes has been greater than the two hopes or two distance. Okay, means they have to pass from the two edges to at least two edges. Okay, means greater than two distance you will require to reach that node. Okay, in between the node. So this is the third division, and the fourth one is an edge that does not from the side of any triangle in the graph. Which of the following definitions is correct? So anyone wants to answer this? Which one definition has been related to the local bridge? Anyone? So I will recall the local bridge. What is a local bridge? I will recall that. So we have seen that the local bridge, which has an node. So we have a node, and there is an edge in between them. So the local bridge concept says that there is a no common friends in between these two nodes. These two nodes are there. There is a no common friends has been possible here. So this has, but this is not possible. Means it's not says that there is a no there is two node two endpoints are there and in between the edge is there and there is a common friends in between of the two endpoints are there, then there is a no local bridge, we can say that. Okay, so the local bridge is that only the two nodes are there and there is a no common friends in between them. So let's see which definition is related to these concepts. Okay, so age with zero neighborhood overlap. So what is neighborhood overlap? Neighborhood overlap we have seen in the concept. You might seen the week videos, week lectures. In that we have seen that the neighborhood overlap means that is, and these two nodes are there, E and B. Local neighborhood means how many there are common friends are there for the A and B. So you can see here these are the nodes are there, and this is also friends of this B node. So here the no neighborhood overlap is in 3. You can see that. Okay. So here it is saying that zero neighborhood means there is a no common friends are there. That means only this age is present. There is no uh, friends. It's common in the A and B. Okay, so this definition is correct, right? It is aligned with the concept of the local breach, right? Another is another definition, which is an age whose endpoints have no friends in common. That we have seen earlier, right? There is no common friends. It's in the endpoints of the age. So this is also true. Third definition says that after deletion of the results, let's draw a network, sample network, and let's remove the age and how the graph look like. Let's see that. Okay, let's take an. So we have two nodes, and let's take and A and B. So for the local bridge, we are also calling as an weak tie, right? Weak tie means the concept of the weak tie is also similar, that it is, and there is no triadic closure for that. Triadic closure means for that, what it means. Suppose, let's don't divert. First, we will understand this. What is an this definition says that. Okay, so there is an network of this also, and it is connected in between them. There is also network, and another node is there. There is this node is there. Okay, so here you can see that the node, this node A, this node B, the age this represents, which is an local bridge, right? It is, and there is a no common friends is there here. These friends is not common. This is not directly connected to the B, and it's common in between the A and B, right? It is connecting via these friends, via this user, right? It's not common. So after deleting this, now the distance between, I suppose I wanted to reach from A to B. What is the distance? The one, only one edge you will require to pass it, right? But after removing this edge, how many distance it will requires to A to visit A to B, right? So one, two, three. Three distance is required. The greater than two, right? So while after deleting the local bridge edge, the distance between the endpoints, or if you want to reach from this endpoint to another endpoint, it requires greater than two distance or two hopes, right? That is saying in the third definition, which is also correct, right? That we have seen. After deleting the edge, it increases the distances in between the endpoints. The fourth definition, which is that the edge that does not form the side of any triangle in the graph, right? Are you guys imagine what it means? Means, let's say there is an one triangle is there, right? Triangle means what? Suppose let's consider this. You are saying this is an let's take, and this we can say as, and we can call as an local bridge. But what local bridge definition says that it doesn't have the both the endpoints of this local bridge doesn't have the common friends. But you can see, in considering any sides of the triangle, there is and a common friends is obtaining here. You can see for this age, for this local bridge, there is a common friend here. For this age, there is a common friend is this, right? So this definition is also said. It is saying is not, right. An age does not from the side of any triangle. So it is also fall into the definition of our concept of the local bridge. So here the correct option is that all the above, all the definitions are related to the concept of the local bridge. Okay. I hope you guys understood what exactly the local. We have seen here the various dimensions of the local bridge could be happen, right? Yeah, is there any doubts in here? Okay, if not, we can continue with the another question. Yeah, so another question is that, let's assume that we have A is a friend, A is a friend of B, and B is a friend of C. Eventually, A becomes friends of C. So what this phenomenon we can call? right? Suppose that what it is saying, so there is an A node and the B node, right? So the it is saying A is a friend of B, right? A is a friend of B, and B is a friend of C. B is a friend. Eventually, after some time, after some period, there is an a distance, there is an age has been drawn in between the or a relationship has been developed in between the B, A and C. So what this concept we can call? Yes, Gautami.
Triadic closure.
Yeah. It is an triadic closure, right? It's concept related to the triadic closure. Okay, let's see the question three. So I hope in this also this concept is very easy. Might be everyone has understood. Yeah. The question three. According to the Gronometer theory, weak ties are crucial in social networks because they reinforce existing relationship. Reinforce. It's not reinforcing the weak ties. We have to understand. Spread the information across different groups. Imagine that how the local age is there and there is an local is local bridges local sorry weak ties is drawn in there. So there is a one question also, the what is an local bridge is also a weak tie or a strong tie. I think this concept is also covered in the weak lectures. So what do you think, guys? The local bridge as an weak ties or strong ties? Yes, anyone? Local bridges are weak ties or strong ties. Imagine the or recall the concepts of the weak local ties and local bridge and weak ties. In weak ties, there is a no triadic closure will be obtaining. Means there is a no common friend in weak ties, right? And also local bridge, there is a zero neighborhood overlap is there. Means there is a no common friends in between the A and B as well. Which means the local bridge we can call as an weak ties as well. Okay, so the we need to analyze that what granular theory says about the weak ties. This we are at second point, right? It spreads information across different groups. Another is that third one, create strong community bonds. Strong community bonds. The age is strong or not based we are currently identify or measuring based on the common friends, right? And weak ties does not have a common friends, right? So this absolutely not related to the weak ties. Limit the flow of information. It's not the limiting the flow. It's not, we are not giving the weights currently here, right? So the actually, what do you guys think here? Which option is correct? Reinforce existing relationship. So from these three options, what do you think? This is obviously it's not related. It's not fall into this weak ties.
Limit the flow of information.
So how it is limiting the flow of information? Say, see here A and B. So whatever the A has information, it can directly pass to the B. There is no there is no barrier in between them, right? Or otherwise this age will be this age is effective for this community as well. Means there is an whole network for this A. The all networks can be talk all can pass their information or discuss via this age. This is very important age, right? So it's not limiting any flow of the information. It's not an bottleneck that you are imagining here, right? So don't imagine that like that way. See, consider the connections, right? So let's draw a network, right, and understand what the weak ties, the Granovetter theory has says that. Let's say, so we have node, that is an B, there is an age in between them. Weak tie says that there is a no common in between them. So it could be possible that B has their own network, own whole network. It is connected to other domain of the network. You can say that this B is from the medical domain, that the B person is from the medical domain, and it is connected with their medical friends, medical uh, institutes friends, we can say that. Okay, and it is connected strongly. And there is another node, which is B, which is an engineering. This student is from the engineering background, and he's connected with his engineering engineering friends, right? It's related to, you can say, and they are connected to each other densely, you can say, right, like this way. So through this information, through this A, they can pass. They can suppose someone he wants to take advice about the any medical description or prescription. So suppose this is an X node. So it will goes to the A. So do you know anyone from the medical background? I need to understand what is the description of this medicine, likewise. So he will go through the B, and B has whole lot of friends. Right? So you can see there is two different groups are forming here, right? And based on this group, it is spreading information. It is, you can see this information B can spread in his network, and it's vice versa. So B can also pass the information to here as well. The spread, maybe the second, you can see the spread information across different groups, that could be done by this age only, right? If there is no age in between the A and B, the this group A and this group B does not pass their information, does not have a linkage in between the in medical student guys, right? Yes, I understood. But is there any doubt in this? Means you have not understood clearly. Likewise, I can repeat that as well, taking another example as well. So the first option is not that it's not reinforcing or any forcing existing relationship. It's not like that, right? Limiting the flow. It's not limiting any person. Anyone can talk anytime, right? It's not everyone is talking at the time. So there is a no information is passing. It's like bottleneck. It's not the bottleneck concept is applied or has been done here. Okay, so only that information I can call. You can imagine the whole real world network, real world our friendship, how our friendship works. Okay, suppose I wanted to take advice in any legal procedure. So I can go to my friends. I will ask to my friend, is do you know anyone from the legal background? So from friends to friend, that is an acquaintance. Last time you have asked, right, what is an acquaintance? The friend of friends. So I will contact to that acquaintance, and the acquaintance has their own network, right? So he will pass the information in his network. Anyone knows about this case, anyone knows about this legal claim. So that this is how the information can spread by this only one age, right? Yeah, I think you understood this thing. Let's move to the another question, which is an about also weak ties. There is a lot of questions about the weak ties, because this concept is very important and interesting in relating in the real world, right? So this is also a phenomena related to the real world problem. Okay, so let's see the what questions four says, that weak ties in a social network are often associated with which of the following phenomena. So there are real world phenomena are there. The spread of disease within a community. The second option is that the introduction of new job opportunity or ideas. Okay. And third one is the strengthening the strengthening family bonds. Maybe it's not that is it's not forming a triadic closure. If it is and forming the triadic closure, it's making an stronger and stronger the network, right? If it is, but the weak tie is not saying that. It is saying that there is no common friends in between them. That means that tie is and weak, right? There is a whole lot of common neighbor common nodes are there, then that tie is a strong tie. That is a relationship very strong, right? That is example has been covered, right? Someone is asking money from for me, that is and support 10,000, please give to 10,000 me, to me. So there is an serious concern is there, but I can't trust on that person, right? There is a no common friends in between that person and me. If there is a common friends in between me and that user, then I have a trust, right? So that is related to the trust also, that weak ties and strong ties. So if it is a strong tie means there is a whole lot of common friends are there, then that is in the ties that relationship is a strong relationship. I have a more trust on that person, right? Likewise, the strengthening of the bond, it's maybe it's not related. The maintenance of a daily social routines. It's not maintain how you are maintaining it, right? So what do you think? We have already covered many possibilities of the weak ties. What do you think, which option is correct about for the weak ties?
Option 1.
Yeah, this question is already we have seen in previous question, that is an spread of information between the groups. So likewise, the spread of disease within a community. Let's take an example that the COVID-19, right? There is another community. Let's take, it's not, maybe it's not real or not real or not real. Let's take an assumption. Say the China has an already infected by the COVID-19, right? And there is a one community, there is two communities, China community and India community, right? And some one person is already infected, right? Already infected in China, and he has traveled to India. So the information passed or information of that infection or disease is coming to the another community, that is a one age, and it is spreading in that particular community further, right? So this is maybe one example may it's related to the this phenomena. Yeah, let's see the another question. Question 5. Here, Eij is the embeddedness of an edge between node I and j. Choose the correct option for the given network. This is the network, and here W is also embeddedness for the C and D edge. Right? E embeddedness for the A and edge between the A and B. Okay. So let's recall the embeddedness concept. What how embeddedness we are calculating. Based on that, which option is correct? Take a time. Let me know what is the correct option. After all, we'll discuss in detail also how we need to calculate the embedded. First try to recall it and try to solve this question. Then we can discuss about it. Okay. Yeah. Yes. Anyone? Embeddedness. Embeddedness means what? We are finding the common neighbors. How many common threads or common nodes are there for the endpoints of the edge? Count only the number of nodes of the for the edge AB and edge CD. Right. For that edge, which for which edge has a number of common friends is higher. Yes, anyone?
Option 2.
Option two. So what is the embeddedness for the ABH? Yes, Gautami. What is the embeddedness for the A and B? The concept of embeddedness already said that is, and how many common neighbors that age has. Age does not have the common neighbors. The endpoints of the age, how many the common neighbors are there, right? So AB, so for AB, there are two neighbors are there. You can see here for this age and for this two nodes, the common neighbors are E, which is connected to the A and B, right? And another is an F, which is connected to A and B. It is in common, right? So the embeddedness for the age AB is n 2. Right? Let's see for the CD. The CD age is here, and for the end points, the common neighbor is E only. So the embeddedness for is 1. So it is and already AB is greater than CD. So this option is correct. Yes, is there any doubts in this embeddedness concept? Yeah, let's move to the another question maybe. Yeah, after the Griven-Newman algorithm has run its course, so it's and run its job, what remains in the network? Okay, means you have applied Griven-Newman algorithm to a graph, right? And after completion of his means after execution his job, what could be the result of the that Griven-Newman algorithm? He can return it. The first option is that a fully connected graph. First, understand or recall that what is the principle of the Griven-Newman algorithm, what it does, and for which purpose we have used. Right in hands-on experiment, I think in that we have seen two methodologies. Actually, the first is an brute force community finding or community creation algorithm, and another is an Griven-Newman algorithm, which is based on that betweenness. Right? The second option is the single large community. Right? Another is, and the third one is several disconnected subgraphs representing distinct communities. Fourth one is a network where all nodes are connected by at least one edge network. So, what do you think? What could be the best answer or correct answer for this question? Yes, the first option, fully connected graph. It's not possible actually. It's maybe it's suppose there is one node, there is it will return only one node, that you can say that it's not possible, right? Means there is an betweenness. How the betweenness let's say the how the Griven-Newman algorithm forms the community. It is mostly used for the forming the communities in the graph, right? So what it does, what it how it works actually. So for there is a network. Okay. So time. So there is a network. It is connected things. Right. So here, right. And let's see. This is one graph, and this graph you have passed to the Griven-Newman algorithm, and it will return subgraphs. Means it is mostly used to form a communities. Communities means what? There is a specific group of nodes which are connected themselves densely. So in here you can say that this these three nodes is connected among themselves. That may be one community, we can say that. And another community means that they are from a same ideology, that we have previously seen one example, right? That is and one engineering background group of student people are there, and medical background people are there. So these are two communities. Okay. So after removing that weak tie or local bridge in between the community, they are forming the disconnected graph. It's not connected graph, but those each component, it represents an one community. Okay, if it is digitally connected. Let's see how the Griman-Newman works. So there is another community. So what it there is an how many edges are there? One, two, three, four, five, six, seven. Right. For 7 edges, it is calculating the betweenness centrality. The betweenness centrality means betweenness centrality is says that how many, for suppose sorry, so what happened? So here is an E1, E2, E3, E4, right? E5. So for each edge, it is calculating a betweenness centrality or betweenness score. One score is there. That score represented or says that how important that edge in the network. Important in means that suppose that edge is removed, there is a loss there, means the distance between the or the information we suppose passing from this only one edge, it suppose it is removed, then there is a loss of three nodes can't communicated with this four nodes, right? So this edge is very important compared to the this edge, right? This one edge, I repeat that this age is very important than the this age, than the this age, right? Because if you remove this age, you can't or this community or this group of students, this group of nodes can't communicate or can't pass their information to this information, right? The between is calculated that score actually. Higher the between centrality score, that means higher the information of that age, right? Here the between centrality, how it is calculating, that is how many shortest path is passing from that age, that is calculating in the between centrality. See, suppose for this age, this node is passing from this node, this age to visit this node, visit this node, visit this node as well, right? So so for these three nodes is passing to this age to visit these four nodes. Okay. So that is an four shortest pass is required, and that is four scores are there maybe. Okay. So by removing this age, so it is removing one by one edges. So first it is removing the first bit highest of between its centrality edge. Then it is checking that it is an connected or not connected. If it is connected, then it again it is its process. Then again it's find the between the centrality of each edge, and it will remove the toppest between the centrality edge. Right? And this process uh, goes one by one, means it checks it disconnected or not. If it is disconnected here, in this case you can see here, after removing this, once again it is very just take a minute. Right. After removing this age here, because this age has an highest centrality, by the Griman-Newell algorithm, after removing this age, there is forming two communities, two subgraphs are forming. Right. So the same principle is used in the Griman. This is the principle of this is the working of the Griman-Newell algorithm actually. Okay. So considering this, what could be the correct answer here?
Option 3.
Yeah, option three. Yes. Is there any doubts for understanding this Griman-Newell algorithm? It's simple. Might be you are not understood how to calculate the between a centrality. For sake of understanding or sake of time, you can understand that between a centrality means we are calculating it is an how many shortest path for pair of or combination of all the nodes, means node 1 2 node 5 node 6 node 8, right? How many shortest paths are passing to that edges, right? that score represent, that count represents as in between is centrality. Yeah, here the option is 3 is correct, right? Several disconnected subgraphs representing distinct communities. Yeah. Next question. Till now, is there any doubts? Is there any, you, if you don't want to talk, you can also write in chat box as well. Okay. Is there any means simple doubts is also there? You can also ask. Okay. We'll discuss here. This is an interactive session. Okay, so it's not one way. I'm only talking and you are only listening in that person on that side. Okay, you can discuss here if you not understood or you have any feedback or any information you want to add here. You can welcome for that. Okay. Yeah. In question 7, while implementing given neural algorithm on a certain graph G, you observe that age E2 gets removed after E1. What can you comment about them? Understood. E1 has first given Newman algorithm has removed the E1 age. That means E1 age. After that E1, he has that given Newman algorithm has removed the E2 age. So what do you think is why the E2 has secondly removed? Why not E1 is secondly removed? E1 has higher betweenness than E2. Another option, E2 has higher betweenness than E1. Third option is that E1 has a more shortest path passing through it. Right? And fourth is that E1 has uh, higher betweenness than E2. Also, E1 has a more shortest path passing through it. So already explained the Griman-Newman algorithm. What do you think? What which option is correct? Yes.
Option 4.
Yeah, option 4. So anyone is thinking another option? Yeah, I already said that the Griman-Newman algorithm works based on the between centrality of age, right? Between centrality, which is in one score, which has which has uh, mm, which has calculated based on the how many shortest path passed through that age. Okay. So here, so the driven algorithm first remove it works based on the removing the edges one by one. If it removes the one edge, then it's checking it is connected or not. If it is not, if it is connected, then is also it traces the process. Then we will also check the centrality between the centrality, which one is higher, then that edge is removed. If they are disconnected, then that algorithm stops here. You can iterate this process uh, further. I means how many times you, if you want, for 3 disconnected subgraphs, if you want, you can add that parameters there. 3 sub it is disconnected 3 components in 3 components, then you have to continue that process. Okay. So here that is removing the first edge E1, right? So E1 has an higher between a centrality. Let's take one example, that is in one network here. Okay. Right. So and this is an another edge also. We can say that this one is an E2 and this one is an, sorry, let's take it this way. Okay. E2 and E1. So in this network, forget this what question has says up to now. Let's consider only this question, this network. What could be the means for intuition by intuition? What is the highest between a centrality for E2 and E1? Which one is higher? E1 is higher or E2 is higher between a centrality? How many shortest paths passing from E1 and E2?
E1 has the highest shortest paths.
And after that E1,
E2.
hmm, right. So here, so here, E1 has a highest between a centrality. So by Grignard algorithm, it removes this edge. Right. Let's remove it. Oh, so remove it. Right. Okay. So after removing, still it is connected, right? So goes second iteration of the Grignard algorithm. So then again checks the each edge between a centrality. So in this case, the E2 has a higher edge in centrality here, between a then it will remove this edge, right? This edge. Then now you can see there isn't two disconnected or disconnected graphs are there. Right, this one is subgraphs are there, these two communities represented here. So here you observe the working or procedure, how we have removed the edges one by one. The first E1 is removed by because of the E1 has an highest between a centrality, because why the between a centrality is higher for the E1, because the many shortest paths are passing from this edge, that's why it has the higher between a centrality. That's why we removed the first E1. After removing it, we have again calculated the between a centrality. So in that case, we found that E2 has an highest between a centrality, right? So then we have removed the E2. So the option E1 means you can see here the this option is also correct, right? E1 has higher between a centrality than the E2. Then this option 2 is not correct. You can see E2 has E1 has highest between a centrality than the E1, right? So this is not option correct. Option 3 is also correct. E1 has a more shortest path passing from it. But which one is the more correct? Which one is means you can see these two concept phenomena has been incorporated in this fourth option, which has a higher between a center as well. It has a highest or more number of shortest paths passing from the E1 edge. Okay. Yeah, I hope you understood this thing. Yeah, go to the next question. So, which of the statement are true? The nodes at the end of the local bridge in a graph have no common friends. Okay, the local bridge has considered, right? There is an edge, and for the end of this edge, there is a no common nodes or common friends of these two endpoints. The statement one says that. Then statement 2, removing bridge from a graph leads to disconnected graph. Right. So it is saying, so let's think what which option is correct. Statement 1 is correct or statement 2 is correct or both options are correct. Both statements are correct.
Both statements are correct.
Yeah, both statements are correct. Any so everyone is agree with this option, right? Statement 1 and statement 2. It might be some students might not understood. Uh, let's see by taking an example or taking a network, and these are concepts of the local bridge. Okay, the local bridge already says that there is a whole network is there. right? Whole network is there, and there is one single node is connecting to the another network, another group of densely connected nodes. Not bad in figure, but let's see. Okay, so this is this represents a local bridge. Why it is local bridge? Because these two nodes doesn't have a common net nodes. Okay, doesn't have the common nodes. So it's already says that local bridge in a graph having no common nodes. Good friends, removing bridge from a graph leads to disconnected. Suppose I remove this node, then there is a two disconnected subgraphs are forming here. So that this option is also correct. This statement is also correct. Right. So option 3 is correct. Let's say the next question. Find a neighborhood overlap of the edge connecting V0. So might be you are not, it's not visible clearly. Let's zoom. So is it visible clearly to you? Which one is the V0? Which one is the V3 here?
Yes, sir, it is visible.
Yeah. Yes, sir. So you can see here. So what could be the neighborhood overlap? You have to calculate it for the edge V0 and V3, connecting the edge between the V0 and V3. So I will draw here that edge here. This one is the edge. So for this edge, we need to find out the neighborhood overlap. So take a time, calculate it. Please let me know what is the correct answer. Yes, anyone? It's very simple. It's not that much difficult. You can see the neighborhood overlap definition says that how many common friends, okay, how many common friends divided by total number of, means union of endpoints, nodes, neighborhoods. So numerator, number of common friends divided by denominator, union of friends of A, friends of B. So I have given the formula here, maybe, right, for this neighborhood overlap. How many his friends or his or her friends, the endpoints, is overlapped. Okay, their friends are overlapped. So
Option
anyone
4.
comes with a, yeah, other than Gautami, is there anyone's trying it? Okay, yeah, Gautami, you are saying something?
Yes, sir, option 4, 1 by 4.
1 by 4. So how 1 by 4 comes? Can you explain here? So what is the numerator? How many common friends?
The common friends of V0 and V3 is V2.
V2, right? That means 1.
Yes, sir.
Is there any another possible friends are there? No. Okay, so in denominator,
Total friends, V0 has V5 and V4 and V2, V1 and V3
Right.
has V2. Totally 4 friends.
Right. This one, two, three, four. Yeah, this is simple. Are you guys understood? This one is a common friend. Right. You can see here it is connected to this V0 as well and V3 as well. Okay. So this the common friends. How many counts of the common friends? It has only one, and divided by total friends of V0 and friends of V3. If there is, suppose, another node here which is connected to this node, in that case it not be counted here. Because it's not friends of this node. Okay, I hope you guys understood. Let's take another question. For the given network, identify the node that has multiple local bridges and spans the structural whole in the organization. First, please, can anyone recall or can anyone explain what is a structural whole? Is anyone? What is a structural whole?
It is a common path to traverse one group to another group.
Right. It's something related about the local bridge, it's but not exactly equal to local bridge. Okay. Local bridge might be, and see here, what do you think of them? It is unrelated to, means how it is related or not related to the local bridge. Means how it differs from the local bridge. Yes. See here, so let's see there is a one node, right, and it is connected to only one node. Sorry, so I will draw better drive maybe. Okay, this node is connected to only one node. So could you call this which is an structural hole here? Is there a possibility it is here that structural hole is there? Yes, anyone? See the structure, the local bridge says that it's not looking into the network of this node, it's only looking on this end points. If this end points has an this common friend or not, it's not common friends, then it is a local bridge. Something is that. But in structural whole, it looks that there is a whole network is there for the two endpoints, which assumes that that two network has an distinct properties or distinct information. So let's assume that this network has an distinct information about the medical domain, and this is an engineering domain, which is connected by this edge, and this edge is node is passing this information to the this another source of the group. Right? So it's look it's this principle should apply for, means it is for this concept or for this phenomena we are calling as a structural whole. Right? From this edge we are, or from these two endpoints we are passing or receiving the information from the different sources. But it is not possible in local bridge. We can say also it is a local bridge, but local bridge is not as a structural whole, right? That we have already discussed here. Yes, everyone understood, or should I repeat it?
Once more, sir.
Yeah, you're not understood, right, Gautam?
It's a little confusing.
Oh, yeah. I'll take it. I'll explain it again. Maybe a second. So we have a network here. There is a single network which has some information, some domain information. Let's take another that same example that we have discussed earlier, which is an engineering background. Students are there in one group, which are densely connected in between them, and another is group as an medical domain, which are connected in between them, which is densely, right? So that is an one concept we have discussed earlier. So here, let's take a one group here as of now. Ah, so here that is, and say this is engineering background students, and the one node, this node only connects to one node. So what do you think that? So it is a structural whole. Yes, structural whole. What it says that, right? The principle of the phenomenon of the structural holes that is saying that it is connecting the two concepts, two different distinct information, and it is passing some source information to the another source information. It is a receiving and taking the information. But here you can see there is no has an any information for this node is there, right? Okay, but in local bridge, what we are saying, we are not looking into the network of this node A and node B. We are not looking into that node. Only we are seeing their endpoints in local bridge. Endpoints. This endpoint has a common neighbors or not in local bridge. Okay. So here you can see there is a no common friends uh, uh, in between the A and B. So this is an local bridge, right? We can call as a called and local bridge, right? This is, but suppose it has a network, still it has a densely connected network which has source from the medical and it is an engineering or different source field. Let's take an here still has an local bridge properties applied here. It shows and also local bridge property, but it also shows that structural whole as well, because this information from this source to this source is passing from this only one edge, right, from distinct nodes. Yes, I hope you understood. Hello.
Yes, sir. Understood.
So this can control the information flows from this domain to this domain, right? Controls means if it is deleted, there is no pass of the information from this domain to this domain. The structure has capacity to control the information in disconnected graphs. Means suppose we have been disconnected it by removing the edge that, yeah. See this next question. In a small social network resembling Facebook, individuals are linked by ages representing friendship connections. The ages in this network are weighted to signify the strength of these connections. Which statement accurately reflects the nature of this network? Strong ties generally exhibit low age weights. Strong ties, strong ties generally exhibit low age weights. Do you think it is contrast statement actually? Low age weights. And here age weight says that how much the bond in between the two users is strongly means suppose it is an lie the score weight in 0 to 1 and score aligned inclined to 1, that means that is strongly connected in between their bond actually. It is near to 0, that means their age is very weak actually. Strong ties typically possess high age betweenness. Right. Strong ties are primarily observed as intercommunity ages connecting two distinct communities. None of the above statements are accurate. So, what do you think here? So, first recall the weak ties. What is an weak ties? And opposite of that weak ties, that is the concept of the strong tie actually. So, what weak ties says, and opposite of that concept, which is a strong tie. So, considering that, what do you think that which option is correct here? First, understand there is a network. Strong ties generally exhibits low age weight. Strong ties typically poses high age betweenness. Strong ties are primarily observed in intercommunity ages community connecting two distinct communities. Two distinct communities, it is saying. So it is a strong ties or weak ties, right? So it is saying a network, right? This is fictional network, and the age represent linked by ages representing friendship in connection. The age in this network are weighted, means it is in point 1, point 1, point 2, point 5, point 9, right? That much score it is bound. So considering this network, what do you think? Which option is correct? Anyone?
Option 4. None of the above statements are accurate.
Yeah, what do you think? Why do you think option 4 is correct? Why not that 3, then 2? One, we can understand the low wage weights can't be there, but 2, 3, what do you mean by a strong tie? 10th question, yeah, sure. Sorry, I have not given the answer for this 10th question directly. We have, sorry, or we have not discussed the answer, right? So we have discussed the structure, what is structural whole and local bridge here. So considering these concepts, what is the answer of this question? For the given network, identify the node that has multiple local bridges, and spans the structural whole, right? Structural whole in the organization means multiple organizations are there, and which node spans in it, means which node is has connected to the all the organizations, right? So what could be the answer considering the that concepts structural whole and the local bridges?
F.
If any other answer? Yeah, you can see here F is connected to this organization. The organization X is there. Let's say there is another organization Y is there. Another organization. This is in Z. Right. Itself has an organization. You can say that this is itself has an organization. Z. So by this node, this X and Y is connected through this F. Connected to through this F. So here you can see the local bridges. How many local bridges are there here? They you can see this one is the local bridge that has doesn't have the common neighborhood is not there. Also this edge. Okay, these are the local edge. By removing these edges, the network isn't disconnected. The graph is disconnected, right? Also, this F represents a structural hole, means this represents. structural hole here, right? Because this connects this organization as well in this organization by through a single node. It controls the information by uh, if it is removed, then it's not pass the information from the X organization to the Y organization. Okay, so here the option is option F is correct here. Yeah, I hope you guys understood. Yeah, let's come to the question 411. Yeah, what we have discussed. Yeah, what is a strong ties? Yes, what is strong tie? Before that, let's discuss what is a weak tie. We have taken multiple questions about the weak ties here. What do you think? What is a weak tie? Is anyone? Can also chat, write in the chat box as well. So weak ties, we have discussed that there is a no common friends. Okay, there is a no triadic closures is B. Means of forming there. Triadic closure means what? If they are strongly connected. One second. Connected. Their common friends is after this some period of time there have has been common friend has been connected to them, but it's not applied or not has been done in the weak ties as well. Weak ties, there is a no common friends are there. So opposite of that, the strong tie says that there is a whole lot of common friends are there. The higher number of common friends, higher the strong ties. So here you can see the here the strong ties generally exhibits. It's not based on the age weights. You can consider as well the age weights along with the number of friends as well. Okay, if you want to consider the age weight, you also need to consider the number of age weight. Suppose when we can apply this means we suppose if you want to um, suppose there is a graph is there, whole large graph is there, and there is a one possibility that two age means you are evaluating the graph, evaluating the age by it is by scoring that a how much it is and strongly ties there, right? Now we are only saying it is an strongly tie or not, right? 0 and 1. But if you want to quantify that strong tie in a numeric value, fuzzy value, in that case, what you can do, you can also consider the number of common friends. Along with that, the weight of that ages, right? So it will be also address the problem is that suppose the age two ages are there and that two ages has same number of common friends are there. The A1 way age has same number of common friends, A2 age has also same number of common ends. Age means their end points has a number of common friends. I'm saying that, okay. So in that there is there is a number of common phrases same, right? So you want to set which one is more strong. If you want to quantify that, in that case, what you can do that you can consider their common neighbors age weights, right? And here age weights calculated, then average it, or you can do any mathematical operation on that, and then you will get it, then you will get a one score, right? That score defines or the score quantifies the how much it has and strong ties in between that particular node. Okay, yeah, I hope you guys understood. If not, please let me know. I will recall it, or I will explain it again. Let's move to the next question. The find the betweenness of the age 3 7. 3 7. The where is the 3 7 age? Here, 3 7 age. You have to find out the what is the betweenness of the age 3 7 for the given network. The betweenness, what between how the betweenness is calculated? How many number of shortest pass passing from that age? How many number of shortest pass? Don't calculate by one, taking one age combination of the all the nodes, and then you are calculating. Intuitively think on that, this network, how many could be possible, the uh, shortest pass, shortest shortest path passing from this age. Let's see, there is an three nodes are there here, the different nodes are there. So for visiting these three nodes, that needs to pass from this age. Think on that, think on this question. Please let me know, calculate it, let me know what is the answer, correct answer. I've given already one hint actually. So there is another, means there is a one group of nodes are there from other side of that age, which is, and three nodes are there, and other side of the, another side of the age, which is on the seventh node side, there is an, maybe including seven, there is 11 nodes maybe, right? One, two, three, four, five, six, seven, eight, 11, right? So you wanted to uh, you want to reach to the another say 11 nodes, you wanted to, you have to pass to the from this age actually. So how many shortest paths are possible? Anyone? It's very it's not that much time taking. Let's have a, let's discuss, or let's solve how it. So how many questions are there? Question is, yeah, this is the second last question. Is anyone have got the answer? Yeah, otherwise we'll solve here. Let's see here, as already said that. So here there is an three questions are there. Three nodes are there. So three nodes are visiting to each of these nodes, each of this part of the node from this age, from this age, from this age, right? From this age. So how many possible? So these are the mm, these are the three nodes, these are the 11 nodes. Suppose this three node wanted to visit 11 nodes. So he, that three nodes, the number three node, it will go from this to this, first this what we can say, will pass from this age, and then will visit to all other ages, right? So there is 11 it requires, right? Then for one node, it will also pass from this age to visit this 11 nodes, right? For 11. For two nodes also pass from this age, right? Also 11. So it is in 33 possibles, right? So are you getting, means how we have calculated? Yes. If not, please let me know. I will repeat it again.
Sir, once again, sir.
Hmm. So so we have to find out the betweenness for this age 37 in between the. So betweenness says that how many shortest passing from that age, right? So how many shortest paths could be possible? So other side of the edge, you can see there are three nodes are there, right? These three nodes are there, and another side, which is an seventh side, means another end point of that edge. There is an, you can calculate here that 11 edges are possible. These are the three, these are the 11, right? Suppose three node number three node wanted to visit all three nodes. That node needs to pass from this edge. There is no other option, right? So he has an 11 shortest pass is has been done, right, for the three node, number three node. Let's take for the one second number node. It is also passed from this edge to visit this 11 nodes, right? It is an 11 for the one node. It is an also 11, so the total 33, right? Understood?
Yes, sir.
Hmm.
Yes, sir.
Yeah. So option fourth is correct. The last question: find the edge with maximum betweenness for the given network. Intuitively say that, means don't need to calculate one for each edge betweenness. Intuitively look into this network. What could be, which could be the edge which has been highest betweenness centrality?
Option 3, 7 to 8.
Yeah, and why is that? Option 7, 3, 7 to 8, that is fine. But why 7 to 8 only? Why not 3 to 7 and age between 6 to 7? Yes.
Because the 7 to 8 is a bridge of that four clusters, 1, 2, 3, and 4, 5, 6, 13, 14, 12, and 9, 10, 11. It is a bridge of all clusters. Without the 7 and 8, all are disconnected.
Mhm. Right, right. Disconnect, and this all means, right, these two clusters suppose needs to communicate this this side of the network, they needs to pass from this node, right? There is also possibility this node, this edge is also there, it is connected to this node or this community, but you can see the number of nodes, number of shortest pass is very less from visiting to the visiting this node, right? But the some number of shortest path passing from this edge is higher, because number of nodes from this side of the cluster, this side of the endpoint of the node is high, is very high numbers, and from other end also the number of nodes is very high. So the possible combination of shortest path is very high, right? That is in 7 to 8 is in correct option here. Yeah, I think we have covered uh, many things in these questions. I have also uh, considered then other than the assignment last, we have already considering the last year assignment question. Along with that, I have also inserted another many 4 or 5 questions as well, that for the reason to understand the basic concept of the what is an weak ties, what is an between a centrality, what is an structural hole, what is an embeddedness, what is an neighborhood overlap. I think these concepts you might be understood in this session. Me, if you not understood in the week lectures, maybe we have you understood here, I think, right? So if not, let me know. I will explain again and again. If you want, I will take any example, right? So if you want to if you have any if you want, if you have any doubts in between the week, right? Because we are connecting once in a week, So if there is a chances to get a doubt in got a doubt in between the weeks, right, in between the weekdays, so you can mail me as well, and we can have a discussion, or you can write the questions there, and we'll cover in this weekend our discussion. Okay. If you have any doubts other than this as well, or lecture, or in the lecture if you got in stuck in any point, you can also announce, there is an announcement section or a discussion forum is there, and discuss over there as well. Okay. Yeah, that's it for this session. Yeah. Anyone wants to say something? If not, we can conclude this session. Thank you. Thank you for joining. Let's meet second week.
Thank you, sir.
Yeah, thank you.
Thank you, sir.